Hi everyone, I'm Mrs. Fitz, and today we're going to be talking about power series. So, specifically, a power series is basically a series with variable terms. And one example of such a series would be 1 plus x squared plus x cubed, right? And it's a series, so on and so forth, right? This is actually a very specific type of power series. So the type of power series this is a geometric power series. And that's the case because each term is 1, then x squared. They have a common ratio of x. So in order for the series above to converge, what must be true about x? Well, we learned in our last lesson that in order for a geometric series to converge, the common ratio or the absolute value of the common ratio must be less than 1. So in order for the series one plus x squared plus x cubed plus to converge, the absolute value of our common ratio, which is x, so the absolute value of x must be less than 1. And this is by the geometric series test. Okay. And for these values, and actually another way to say this is if the absolute value of x must be less than 1, then x must be between -1 and 1. And if this is the case, so if the absolute value of x is less than 1, then we actually know that 1 plus x squared plus x cubed actually equals, well, we can use our convergence formula. So it would be the first term, which is 1 over 1 minus your r, which is x. So this power series, geometric power series, actually converges to 1 over 1 minus x in any case where x is between -1 and 1. So this means for those specific x values, the function f of x equals 1 over 1 minus x can actually be written as a sum, an infinite series. The sum from n equals 0 to infinity of x to the nth power. So kind of interesting. Okay, let's take a look at some examples. All right, so in these examples, we're going to find a power series for each of the following functions. Show 4 terms and the general term, also give the series using sigma notation, and give the interval of convergence. Okay, so if we have f of x equals 1 over 1 plus x, we can think about this kind of using reverse engineering of our common or of our convergence formula for geometric series. So if it's 1 over 1 plus x, you can think of it as 1 over 1 minus negative x. Okay, so this would be a geometric series where your a is 1, and a, remember, is your first term, and your r is -x, okay? Okay, so it asks for the first 4 terms and the general term. So f of x would equal, and let's start with just the first 4 terms. So the first term would be 1. Then we multiply 1 by -x to get the next term, so minus x. Then we multiply by -x again to get the next term, so plus x squared. Then we multiply by -x again, so minus x cubed, and then plus ... right? That's going to keep going. So we have the first 4 terms of this series, okay? which equals the sum from n equals 0 to infinity. And let's think about how we write this. So the first term is 1, right? And then we can do negative x is our r to the nth power. Let's make sure that generates all the terms correctly. So the first term, we plug in 0, we get 1. When we plug in 1, we get negative x. We square it, we get x squared, right? So it looks like that is going to work. Okay, so the first 4 terms and the general term. Oh, actually, let's go back up just a second. When it asks for a general term, this is actually what it wants. It wants the nth term somewhere in there, which would be negative x to the nth, and then it keeps going. And then I'll go ahead and write that in sigma notation. Okay, now this only converges, it only equals 1 over 1 plus x when the absolute value of negative x is less than 1, which means that negative x needs to be between negative 1 and 1. Divide by negative 1. Therefore, we have 1 is, we need to flip those inequalities. 1 is greater than x, which is greater than negative 1. So once again, x needs to be between negative 1 and 1. So this actually gives us the interval of convergence. Which is from negative 1 to 1. Okay, so go ahead and pause here and do 2 and 3. They're a little tricky. Number 2 is not too bad, but 3 you have to be a little creative. Okay, so hopefully you had some time to do that. Let's go ahead and look at number 2. So we have g of x equals 3 over 1 minus 2x. So this one, very clearly, you can see that your a is 3 and your common ratio is 2x. So when you're looking at your power series, we have our first term, which is 3, and then our common ratio. So we're going to multiply by 2x. So 3 times 2x would be 6x, plus 6x times 2x, we get 12x squared, plus we're going to multiply by 2x again. We get 24x cubed plus, so it wants the first 4 terms and the general term, which would be 2x to the, let's see. Oh no, it would be 3, sorry, times 2x to the nth power, right? And then we're going to write that in sigma notation. So that's, oh, whoops, I forgot my plus dot dot dot. All those little details. Okay, because it keeps going, right? It's the sum from n equals 0 to infinity of our first term, which is 3, times our common ratio 2x to the nth power. Okay, well, in order for this to converge, the absolute value of 2x must be less than 1. So therefore, 2x needs to be between negative 1 and 1. Divide by 2. And x needs to be between negative 1/2 and 1/2. So therefore, the interval of convergence is from negative 1/2 to positive 1/2. Okay. Last one. This one's a little bit tricky because we need to do some rewriting before we're really ready to do this problem. So this is not in a over 1 minus r form, but you can kind of manipulate it to be. So here's my trick. We can do 1 over, we can actually write this as 1 minus parentheses 1 minus 3x. Okay, so notice when I subtract 1 minus 1 is 0, minus negative 3x is 3x. This is still equivalent. So now I can say that my a, my first term, is 1, and my common ratio, r, is 1 minus 3x. Okay, so we're going to go ahead and write this as a geometric power series. So our first term is 1 plus our second term is we multiply by 1 minus 3x. Multiply by 1 minus 3x again, we get 1 minus 3x squared. Multiply again, 1 minus 3x cubed, right? Plus dot, 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 plus, let's do our general term. It would be 1 minus 3x to the nth power plus dot, dot, dot. Okay, now we want to write this in sigma notation. So it would be the sum from n equals 0 to infinity of our first term's just 1, then it's 1 minus 3x to the power of n. Okay, so we have our power series. Now we need to find the interval of convergence. So that means that the absolute value of 1 minus 3x must be, let me write these a little taller so you can see that's a 1, must be less than 1. And so therefore, 1 minus 3x needs to be between -1 and 1. We're going to subtract 1. We get -2 is less than -3x, which is less than 0. Divide by -3. Don't forget to flip those inequality signs. We get 2/3 is greater than x, which is greater than 0. So x needs to be between 0 and 2/3 in order for the geometric series to converge to 1 over 3x. So the interval of convergence is from 0 to 2/3. Okay, so let's go ahead and move on to power series by substitution. So we're gonna use the power series from example 1 in the previous page to make a new power series for f of x squared. So looking at example 1, let's see, that was f of x equals 1 over 1 plus x. So if f of x equals 1 over 1 plus x, then we can actually write that f of x squared would be 1 over 1 plus x squared. Okay, so now we can determine that our a, oh, and actually before we even do that, let's rewrite this so it's actually in the form we want it to be in. And so we would write this as 1 over 1 minus -x squared, right? Okay, so then we have a is 1 and r is -x squared. And so we can go ahead and write a power series. So f of x squared, let's start by writing out our terms. So first term would be 1 times -x squared is minus x squared, times -x squared, we have plus x to the 4th, minus, because we're going to multiply by -x squared again, x to the 6th, plus dot, dot, dot. We're going to do our general term, which would be -x squared to the nth power, plus dot, 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 and then we can write this in sigma notation. So it'd be the sum from n equals 0 to infinity of -x squared to the nth power. Okay. And it didn't say to find the interval of convergence, so it doesn't look like we need to do that. All right, go ahead and pause here and do number 2. Okay, so number 2, we are using example 2, let's see, which was g of x equals 3 over 1 minus 2x. So g of x equals 3 over 1 minus 2x. And so therefore, we're finding g of root x, which is 3 over 1 minus 2 root x. So the main difference for this one is that your a, well, a is still 3, but your r is now 2 root x instead of 2x. And so when we make that power series, g of x would equal 3 plus, we're going to multiply by 2 root x, so 6 root x, plus, we're going to multiply by 2 root x again to get 12x, let's do this in fractional exponents because I think it'll be easier. So 2x to the 1/2. I'm actually going to rewrite that as 6x to the 1/2 instead. Okay, plus we're going to multiply 12x by 2x to the 1/2. And so we end up with 24x to the 1 plus 1/2 is 3/2. And then plus dot, dot, dot. We'll go ahead and write our general term, which is 3 times 2 root x to the nth power, or 2x to the 1/2, doesn't really matter, plus dot, dot, dot. And so our sigma notation is the sum from n equals 0 to infinity of 3 times 2 root x to the nth power. Okay, so let's take a look at some other examples where instead we're actually going to be differentiating power series, and something really interesting is going to happen in our second example, so I will show you. All right, so let's take a look at number 1. So we're going to use the power series for f of x equals 1 over 1 minus x. We did that very first one we did together to find a power series for f prime of x. So we know that f of x equals 1 over 1 minus x has a first term of 1 and a common ratio of x. So that was our 1 plus x squared plus x cubed, right? Plus dot, dot, dot. Okay, so let's take a look at what the derivative of this would look like. And actually, I'll do the general term too, because that will help us out a little bit. So then f prime of x would be the derivative of this. So derivative of 1 is 0. Derivative of x is 1, plus derivative of x squared is 2x, plus the derivative of x cubed is 3x squared. Let's do one more because the next one would be x to the 4th. So that derivative would be 4x cubed. I always like to do 4 terms and then the general term. Now, the general term is pretty tricky. And actually, on the AP exam, if they do not ask you to state a general term, don't do it, because if it's wrong, then the whole thing is wrong. So actually, because it doesn't specifically ask, we're just going to leave it at that plus dot, 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 and that's it. It didn't ask us to write sigma notation, so this is our power series for f prime of x. Okay, go ahead and pause here and try number 2. Okay, so hopefully you had a chance to do that. Let's take a look at j prime of x. Okay, well, the derivative of 1 is 0. The derivative of x is 1, plus the derivative of x squared is 2x, and it would still be over 2 factorial, plus the derivative of x cubed is 3x squared over 3 factorial, plus the derivative of x to the 4th is 4x cubed over 4 factorial, plus, and we're just not going to worry about a general term right now. Okay, let's clean this up a little bit. This is 1 plus, well, 2x over 2 factorial is just x, plus now 3 over 3 times 2 times 1. You end up with x squared over 2 factorial. Okay, we're going to see a common theme here. Plus, the next one, we have 4x cubed over 4 times 3 times 2 times 1. The 4's cancel out. We're left with x cubed over 3 factorial. And this trend keeps happening. Do you notice anything between j of x and j prime of x? Turns out they're equivalent. So it turns out that this is a specific function, actually. Whose function, or what function has a derivative that's the same as the original function? Think about it for a moment. Well, the derivative of e to the x is, guess what? E to the x. So it turns out that j of x is actually e to the x. Okay, we're going to learn way more about this. This is one of the elementary series that we're going to be doing, which is in the next lesson. But let's go ahead and jump into some more examples. Okay, so the next one says, since 1 over 1 plus t equals 1 minus t plus t squared minus t cubed plus dot 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 plus negative 1 to the n, t to the n plus dot dot dot, right? It's going to continue. The integral from 0 to x of 1 over 1 plus t is the integral of that whole sum, right? So now we're going to integrate both sides. All right, so let's start with the integral from 0 to x of 1 over 1 plus t. That would be the natural log of the absolute value of 1 plus t evaluated from 0 to x. Okay, now we're going to integrate this. So the integral of 1 dt is t minus, we have 1/2 t squared plus 1/3 t cubed minus 1/4 t to the 4th plus dot dot dot. And we'll leave it there, and we're evaluating from 0 to x. Okay, so when we plug in, we end up with natural log of the absolute value of 1 plus x minus, now it ends up being the natural log of 1 plus 0, which is the natural log of 1, that's 0. So we can actually just write it like that, is equal to, and then we'll plug in x, so we have x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th plus dot dot dot. Now, this isn't being subtracted by anything because when we plug in 0 for all those terms, they're just 0 and we're subtracting 0. So we actually have found the power series for the natural log of 1 plus x. Okay, it says use the result of the example above to write a power series for f of x equals natural log of x. Well, the only difference between this problem, the one we did in number 1, and natural log of x is that natural log of 1 plus x has a slightly different input. So using substitution, you can see that natural log of 1 plus x, right, minus 1, okay, is equal to the natural log of x. So all you have to do to find the power series for natural log of x is subtract 1 from the input variable in the series that we already found. So the natural log of x equals parentheses x minus 1 minus 1/2 times x minus 1 squared plus 1/3 times x minus 1 to the 3rd minus 1/4 times x minus 1 to the 4th plus dot dot dot. Okay, so not too bad. And so then we could also kind of extrapolate the last one. Now it wants you to write a series for g of x equals x squared times natural log of x. You just multiply everything by x squared. So it would be x squared times natural log of x equals x squared times x minus 1 minus 1/2 x squared times x minus 1 squared plus 1/3 x squared times x minus 1 cubed minus 1/4 x squared times x minus 1 to the 4th plus dot dot dot. So nothing crazy. We are going to be learning the natural log and e to the x. Those are two of the elementary series that we'll be going over in the next section, but you can kind of see where they come from in this lesson. Okay, that's it for today. Thank you.